Welcome to Building Programs, Building Brains, Bridges to STEM Learning for grades kindergarten through 8. This training is brought to you by BOSTnet, Build the Out-of-School Time Network, and the UMass Boston College of Education and Human Development, with support from the Department of Early Education and Care in Massachusetts. And brain building is in progress. You'll see 4 logos on this slide. If you hover your mouse over each logo, you'll get a website that you can go to get more information about BOSTnet, UMass Boston, brain building, or the Department of Early Education and Care. This is Interactive Presentation 5, Planning STEM Activities, Engineering and Technology Focus. As you probably remember, engineering uses scientific discoveries to design products and processes that meet society's needs. So engineering sort of grows out of the discoveries that come from science and leads to the creation of the technology that we need, which can be things, products, or it can be processes, systems, or strategies. When you're planning engineering activities, something that you want to keep in mind, the first is make sure that you're exploring some of the similarities and differences between science. So as we learned early on, the actual steps or skills associated with science and engineering are very similar. However, there are also a lot of really big differences because science is a broad, open-ended exploration, whereas engineering focuses in on problem solving, so it's much more sort of specific and focused. The next thing is to emphasize puzzles and free-form creativity. Try to do activities that are really sort of broad and open-ended, like a big, wonderful virtual sandbox where the kids can imagine and create their own things, because one core component of being successful in engineering is allowing yourself to think outside the box, to think broadly and in new ways. Make sure that you're engaging in the use of engineering terminology, just like with science and math. Make the vocabulary comfortable and familiar to the kids. Use models and diagrams and encourage the kids to use models and diagrams as much as possible. This can start with really young children with really simple models or diagrams. Just even a picture, a drawing of something, is at its very core a diagram. And then as the kids get older, the diagrams can become more sophisticated and complex, and even they can have multiple dimensions associated with them, or they can be very technical. And then make sure that you teach the refining of the end product. So once you're done creating something, looking at it and saying, how could I make this even better? Because that is a core concept within engineering. This is an example of one of my favorite engineering activities. It's called straw structures. So you're going to divide the kids into small groups, 3 or 4 children per group. You can do this with just about any age within the school age spectrum. Each group is going to get 1 box of straws, 1 roll of masking tape, and that's it. Those are the only supplies that group is allowed to use. And they have to decide what their engineering goal is. Is their goal going to be to build the strongest structure that can hold the most books without collapsing when nobody is touching or helping it anyway, and without the books falling off of the object? Or are they going to try to build the tallest structure that's able to stay standing without anyone touching it, and that is the tallest of all of the structures that have been built? Usually in any given group, you'll have some children try to do one, some children try to do the other. Occasionally, you'll get a group that tries to accomplish both at once, although so far I've never seen that be successful. And again, remember that as long as they only use the box of straws and the roll of tape to build their structure, they can do anything they want. So make sure that it's very open-ended and that they get to be really creative, but you're very, very clear about how you're going to measure success on each of the 2 goals, whichever goal that the children choose. Give them a nice amount of time. Make sure that they have enough time to really get into it. 5 minutes is definitely not sufficient. But for older kids, they might want a longer period of time, and for younger kids, a shorter period of time. And you can also stretch the length of the activity, especially with older kids, by giving them a larger number of supplies, giving them, instead of 1 box of straws, giving them 4 or 5 boxes of straws, and instead of 1 roll of tape, giving them 2, and seeing what they can come up with. So very fun activity, comes up with some pretty neat outcomes. Technology is the products and processes that are the result of the designs created during engineering. So technology is created by technicians to solve the needs and wants that society has, that lead the scientists and then the engineers to reach solutions. When you're teaching technology to kids, make sure that you do the following things. First of all, think outside the box. Think beyond computers, tablets, and phones. We tend to think about those three things as the ways to teach technology. And certainly it is really important for kids to be skillful and equipped in the use of computers, tablets, and phones. But in our current environment, it seems like computers, tablets, and phones have become synonymous with technology, and we've started to forget about the broader applications of that terminology. Remember that technology includes both things and processes, or approaches, and make sure that you use the term technology to appraise new and useful approaches. One example of this, and this will help you see how broadly applicable the term technology can be, is if you have a strategy for managing stress with a child. Let's say that you have a child who gets angry really easily, and when he is starting to get, or she is starting to get frustrated, the child's plan is to walk away, to count to 10, and to take deep breaths. And then let's say that they do that and it works. Then you can say that is some really good self-calming technology that you just applied, because that is a process that they have developed to lead to an outcome that solves a societal need or want. So make sure that you're thinking really broadly. You also want to explore systems for their strengths and limits, all kinds of different systems. Again, it can be processes or it can be physical systems, like the heating system in your building, or electricity, or the space itself and how it's being used. You can also imagine the past and imagine the future. Imagine what it was like before certain technology was invented, or imagine what technology might be coming next. And again, with technology, it is so important to praise creativity, inventiveness and innovation, exploration, new ideas, so that you're sparking that excitement, that eagerness to invent and try new things. A fun example of an activity that explores technology is the What Would It Be Like game. So in this game, you're going to divide the kids into discussion groups of 4 to 6 kids per group, and each group is going to get a card, and on the card you've written a type of basic technology, plus a photograph for kids who are more visual, and a short description or definition of the technology. I've included some examples here: electricity, glue, the alphabet, plumbing, and the wheel. You can use any technology you want. You can have it be computers, anything you're interested in, or that the kids are interested in, or anything that links up with a theme if you're using a theme in your program. It doesn't really matter, but different ones on each card. And then each group gets a card, and their job is to prepare something. It could be a song, it could be a skit, it could be a poster, it could be a group presentation. They can pick what they want about what their life would be like if that technology had never been invented. Each group is then going to take turns sharing what they've created, and it's a great way to reflect on the relationship between our reality and the technology that supports our reality or our existence.